Hello everyone and welcome to the webinar. Today we're going to be discussing the journey from on-premise to cloud, modernizing data protection with Druva Phoenix and AWS. Just a couple pieces of housekeeping before we get started. You made a choice about audio when you logged into the webinar platform today. You can change that at any time using the audio pane in the control panel. There's also a Q&A pane. You can insert your questions. As you have questions through the webinar today or need a little bit more detail, go ahead and put those questions into the question pane and we'll answer them either through the webinar or through an open Q&A session. We'll leave time for a little bit of Q&A near the end. If we're unable to get to your question for any reason, we'll go ahead and follow up with you in email, so feel free to please use that. And then finally, we are recording the webinar today. It'll be available for download in 2 to 3 days, so we'll send an email out with the location for the recording, as well as a link so you can download the slide deck. So those will be made available 2 to 3 days after the session today, so look for that email. Without further ado, let's dive into the webinar today. Today's presenters are myself. I'm Mike Ruiz, a Senior Solutions Partner Architect with Amazon Web Services. We have Shay Verma, Senior Product Marketing Manager at Druva, and Jason Credit, Senior Director of Technology at TRC Companies Inc. And we're really here today to hear about TRC's journey and their success story with AWS and Druva Phoenix. I'll open the webinar with a brief description of AWS Storage Solutions and the AWS Marketplace. We'll hear from Shay over at Druva for an introduction to Druva Phoenix, and we will drop into that success story near the end. And finally, as mentioned, we'll leave time for Q&A, so please go ahead and drop your questions into the question pane. What are our learning objectives? We want to learn new cloud strategies to reduce cost, improve backup reliability, and to enable instant recovery. And we're going to do that using cloud strategies, and we'll describe some of the strategies for achieving these objectives. We want to help you reduce your overall storage footprint and consolidate data across multiple sites. This could mean your overall storage equipment in terms of equipment or hardware used to maintain your storage foundation for backup and recovery, or the actual footprint of your storage itself. Obviously, we recognize that as we go forward in business, we're increasingly having more data under management and more to backup and recovery. We can obviously help you with that as well. And finally, we want to understand the realized benefits of cloud backup. So as mentioned, I'll spend a few minutes talking about AWS-specific technologies. So our customers tell us that they have certain common backup and recovery challenges with operating on-premise infrastructure, and this is certainly my background. I spent more than a decade in doing disaster recovery for scaled IT operations on-premise, and kind of one of the largest challenges I had day to day was maintaining manual procedures for backup and recovery. So we would automate our backup and recovery to a very high degree, but we still had frequent manual exits. Manual tasks like building business cases to support the purchase of a brand new piece of storage infrastructure, or physically moving storage around. I maintained a pretty high volume tape operation, and so the physical process of moving tapes offsite was difficult to keep right, and was a constant challenge and manual exit for my automation. And then as we scale, we need to scale these manual activities as well, and especially scale across sites. This becomes increasingly difficult to coordinate these activities across sites and keep up with the needs of our business. This can lead to higher than maybe strictly necessary costs for our storage foundation. Obviously, building and maintaining on-premise storage is expensive. We've got to maintain it, as I mentioned. We have to maintain the software as well as the hardware. And also when we in place on-premise assets, we often have to oversize them. We're making predictions about the expected use of an asset through its life. So the depreciation schedule is frequently 3 to 5 years. We're making predictions about how we're going to use these assets over long time frames. If we miss low, then we're underutilized. If we miss high, if we overutilize these assets, then we have to do mid-cycle refreshes, which again can be manual and expensive. Then finally, meeting our needs of compliance. So increasingly, we're being asked to bring data under the protection or a particular compliance or regulatory framework. This can mean long-term data storage, and increasingly the need for discovery on those long-term those storage those data assets that we're going to store long-term in vaults, and obviously the need to recover those to build kind of reasonable SLAs around the recovery of assets kind of beyond the useful expected life of a piece of hardware. So this is the real challenging, was the real challenging piece for me, is I have hardware assets on depreciation schedules for 3 to 5 years. I'm paying support. And then I get to make a decision for backups that are physically located on those physical hardware devices at the end of their useful life. Am I going to attempt to maintain that hardware kind of beyond 5 years or beyond 7 years? Or am I going to attempt to migrate those assets to a new hardware platform? And again, that can engender kind of frequent manual migration of assets from one storage platform maybe to a newer storage platform. So kind of two choices. Neither of them are fantastic, and they all have their own challenges. Probably the biggest challenge that I've had to deal with and had to speak to is simply chain of custody for data, especially as I move across storage platforms. So how can AWS help us solve these challenges? One, AWS Storage is a platform that's integrated with multiple AWS services. So a service like Amazon S3, which we'll talk about in a second, our simple storage service, it's scaled and is absolutely appropriate for backup and recovery, but it's also appropriate for simultaneous use by multiple systems. So I can use the same S3 objects stored on S3 to inform analytics, to share with users directly, or to perhaps stand up in a big, or to use to hydrate a relational database. So this presents interesting new use cases for data where I'm not simply backing up into a location, that's only useful for a future recovery. I can back up data or in place live production data into S3. Use that for recovery, of course, but also use that data for instance, a side channel analytics workflow. So I'm no longer building silos of backup and recovery. I'm building production data sources that I can use for recovery, but also use for other purposes. Obviously, AWS S3 and other AWS services are going to be secure. We're going to use the same API to access S3, all assets in S3. And we're going to be able to express policies about exactly who can access all of this data through its life cycle. So we don't have silos in different technologies. We're going to use a single API to control all access, updates, and downloads. We're going to have an audit chain that shows us every single action, every single access of the data, every single update to the data, every single update to the security policy, all under a single API. And then finally, many of these services, including S3 and EBS, which we'll talk about, support transparent encryption. So we can click a button, make sure that data is fully encrypted, and manage the keys on your behalf. It's easy to maintain. AWS is going to maintain the hardware foundation underneath these storage services. We're going to handle all the upgrades to the physical hardware. We're going to in place new storage services in new regions. So we're going to grow geographically with you within regions and across new regions. We have 16 regions available today to run these storage services and 3 more regions announced. And it's going to be scalable. So these services scale up as your needs increase. So as your business proceeds and you have more and more data to manage, we'll scale up to accommodate that for you. And it's going to scale in. So as you change your use of data, and importantly as you explore data. So because the data sources are integrated with other services in AWS, and because they're available through a common API in region and outside of the region, we can actually explore data in ways that might have been impractical on-premise. So if a user came to me and said, hey, I'd like to look at the production data for the last 10 years and run this long query on it, my existing analytic capability or my existing storage tier may not have been able to accommodate that request. And so we're looking at building a business case to buy a bunch of new equipment just to test this theory. That can create a lot of business risk. When I use AWS, I can scale out, run my test, see if it makes any sense to run this in production over the long term, or simply take the result and use that to inform a business decision, and then delete all my intermediate objects and give that hardware back to AWS. So all of these together, the integrated nature of it, the integrated security model, the maintenance, the scalability, both to scale in and scale out, can create lower cost infrastructures that allow you to pay for only what you use. Just quickly go through the AWS storage services I think are most relevant for backup and recovery. Amazon Simple Storage Service, released in 2006, is an object store designed to store and access any type of data. So any size object from 0 length all the way up to 5 terabytes in a single object, and then any number of those objects in a single region. Different tiers the default tier offers 11 nines of durability at the object level, which is a pretty high durability standard. We also offer reduced redundancy, for secondary copies of data or copies out of region to inform like a disaster recovery workflow at different cost tiers. We also offer Amazon Glacier, which is similar conceptually to Amazon S3 in that it's an object store. It's designed for less frequently accessed data, though. A good example might be a media asset that you transcode into new forms as new mobile devices are released, say. But you only do that every 6 months or every year. Put those large artifacts on Amazon Glacier and then schedule a download and operation to re-encode at your option. And then finally, Amazon EBS is block storage that we make available to virtual servers. It's off-host, durable, so we can take snapshots of database volumes, snapshots of data volumes, use that, move that around AWS regions, use that to inform backup and recovery. So these three services together are essential for backup and recovery on AWS. Talk briefly about partners like Druva. So we have these foundational storage components. They are very flexible. They can be used to inform analytics or for backup and recovery. Partners like Druva really do a great job of making them easy to consume for specific use cases. So for backup and recovery, we need particular idioms and verbs. We need to do incremental backups. We need to do block level backups. We can certainly store this data on S3, but partners like Druva really make that easy and achievable for customers. So they're going to take these foundational services that AWS provides and the geographic availability. They're going to turn them into useful applications or use them to inform applications and use cases that are kind of closer to how you want to use these services. You're going to enable features, novel features like asynchronous replication, policy-based backups. They're going to use the foundational. They're going to twist the right knobs and select the right storage classes to make this very cost-effective for you. And all of this is designed to help you achieve rapid recovery. And with that, I'm going to hand it over to Shay to talk specifically about Druva and the Druva offering on AWS.
Great, thank you. All right, so just a little bit more about Druva. Let's see. So we started off as an organization that came out of India, Pune, about 8 to 9 years ago. We have over 4,000 customers as of today, which come from every walk of life, essentially from every vertical. If you look at some customers that are in the pharma or in the healthcare industry, like Pfizer, Shire, and we also have some very security conscious or customers as well, like NASA, KPMG, Booz Allen Hamilton. We are rated #1 for the last couple of years by Gartner as the #1 cloud data protection solution available for the enterprise, and we store over 25 petabytes of information in the cloud. We are one of the top-rated partners of Amazon, and so we've had some significant traction from that perspective as well. If you look at what's happening in the enterprise today, there are a lot of moving parts when it comes to backup and recovery. Naturally, disaster recovery as well from that perspective. If I was to ask anyone today in general what they are currently doing from a backup and recovery standpoint, their answer would be somewhere around the lines that they have some sort of software with some sort of server or hardware with some sort of dedupe appliance as well to help minimize the amount of data that gets stored in the back end. And naturally, even tape, essentially a lot of organizations still use for archiving purposes. One of the problems with tape is that there's a lot of information in there, but there is no visibility into the type of information that resides in tapes. And from an archival standpoint, that could be a risky proposition. I recently had a customer or prospect where I was talking to them, and they were managing all the Excel files manually to maintain in terms of which information relies on which in which tape, and there was an Excel file as a log as to what's going on in every tape. And if there was ever a litigation or any need for recovering that information, it becomes a very expensive proposition for them. In addition to the legacy approach of storing information, and as a result of all the hardware maintenance and software, there's a lot of labor that goes into maintaining all of this, and naturally courier services and how do you manage all this information off-site. If you take all this work and add it when an organization has multiple sites, this becomes a very cost prohibitive proposition for organizations. From the perspective of A, just simply the amount of expenses that they incur, and B, also in the event of recovery of information, a lot of times they are unable to recover that information. I mean, if you look at it from tapes, for example, you have to make sure that the hardware is maintained 10 years later when people leave the organization and they ever recover the information. You have to make sure that you have the same set of hardware as well to replay that tape and actually recover information from there. And then when they do eventually do that, one of the biggest problems that we have seen with our organizations is that they realize that backups didn't happen properly, or there was some sort of an issue at the time, which happened 10 years ago, and the recovery of information becomes extremely difficult or impossible. And so statistically speaking, what we've seen is about 42% of companies have experienced some sort of recovery failure in the past year or so, and this is essentially because of looking at legacy solutions, a lot of moving parts in the organization when it comes to the backup and recovery solution, and tapes that get involved. And as a result of non-optimal solutions, we find that a lot of organizations end up paying for copies of data that they really don't need to store, and we see about a factor of 10.7x copies over a period of time where organizations end up copying that information just because they have a legacy solution and they have to preserve it. One of the problems with all these copies is that you now have to have a solution from a storage standpoint and from a server standpoint where you have the ability to make sure that that information is maintained, and that costs a lot from an over-provisioning standpoint. So all in all, those are the difficulties that one organization may face if they are looking to using traditional methods of backups of physical and virtual servers, for example. If you look at where Druva comes in today, Druva's product, by the way, is Phoenix, and it is a cloud-native solution. We eliminate the chain of pain that I was talking to you in the last slide about, where the information, when it has to be backed up, what are the moving parts that you have to do is what we call the chain of pain, and we eliminate the need for hardware, software, backup servers, tapes, data centers, offsite storage, and courier services. We streamline the backup process such that we do a direct backup to the cloud. There are multiple benefits for that. First of all, we use Amazon Web Services for backup to the cloud. We thereby provide a centralized management console. So if you have multiple sites across your organization, multiple servers in every site that you have to do backups of, we have the ability to provide one single pane of glass to manage all that information. And naturally, if there is a copy that needs to be available to you at any given point, then we create a hot copy, or say up to 30 days worth of data that you can store locally as well for quick restore times, and the ability to recover from information to meet your RTO and RPO objectives as well easily. Now, one thing that happens in an organization, and this is where the tape infrastructure gets very nicely eliminated in this scenario, is that there's a lot of information that gets stored in an organization that never gets accessed or but needs to be stored and archived. So we provide auto-tiering capabilities where the customer doesn't need to even manage that. Essentially, if there's information that needs to be recovered immediately, or there's information that needs to be kept on premises, we have about 30 days worth of information that can be preserved on premises. But then we auto-tier that information where we have information that could be warm, where we can cache that in the cloud for 0 to 90 days, and then we are able to move that over to cold storage, which the type of information that doesn't get accessed by over 90 days. This has a direct benefit to the customer. Essentially, we leverage a lot of the cold storage capabilities or Glacier capabilities that AWS provides and transfer those savings directly to the customer. All in all, the information that is hot, that can be preserved on premises, and you will be able to access that information at any given time and restore from there to meet your RTO and RPO requirements. And then moving forward, the information that goes to the cloud, we auto-tier that so that we can transfer the cost savings directly to the customer because we leverage Amazon Web Services Glacier storage from that perspective. Finally, in the event of any disaster recovery, of any disaster, you ever need to recover your information, we are able to provide disaster recovery in the cloud. You will be able to spin up any servers that may be necessary in the event of a disaster directly from the cloud directly. And what we do in those cases, say you have a virtual machine, we take the VMDKs that come from the virtual machines, convert it into Amazon's image, AMIs, and essentially make that available to you in the event of a disaster, such that you will be able to spin up servers directly and run things directly from the cloud as well. So all in all, what I showed you, and in contrast to all the moving parts that were in a backup solution from a legacy perspective, we eliminate the chain of pain. We eliminate all these things that used to make it very hard for backups and recovery, and take information directly to the cloud and make that available to you at any given point. If you look at the advantages that we have, or the advantage of the solution that comes as a result of using a cloud-native solution, first and foremost is scalability and efficiency. Depending upon your cloud needs or your data needs, as you grow, you are able to scale infinitely from AWS directly. We can spin up all the storage requirements that you may have, all the server requirements that you may have, and provide that efficiency and scalability directly from the cloud. Because we were born in the cloud, because the solution was written for the cloud, we can immediately leverage all the Lambda functions, for example, that is available from Amazon Web Services, and make that available to the organization that utilizes Phoenix from a disaster recovery, backup and recovery perspective, and make sure it's completely scalable. Second, the most important thing, security and compliance. Leveraging leveraging AWS, that has a natural benefit. There's a lot of security and compliance certifications that come with AWS from a storage perspective that customers can immediately leverage. We are also leveraging Amazon Web Services GovCloud from that perspective as well, where for government agencies that need the ability to store information in the cloud, they can absolutely have the version of AWS GovCloud to store their information. One of the things that I would like to highlight is that something that is unique to Druva is the way we encrypt information. First and foremost, information is always encrypted in cloud, AES 256, and also in transfer as well. But furthermore, we also have no access to any customer data because of the way we use envelope encryption. Essentially, that is encrypting the key, and we have no access to the key. Customer has full access to the key, and it comes live in the session of a server, and so we will have no access to information from that perspective. Given that, that is a big key benefit of doing of having a solution that is born in the cloud and we have no access to it. So in the event the government comes to us and asks us, hey, can you provide XYZ's information, we unfortunately cannot provide the data from that perspective, which is a good thing and which is a benefit to our customer. A second thing that I'd like to highlight as a result of AWS's reach is data sovereignty. If you are in an organization that has a global footprint, say for example in Germany you have a site and all the data that gets created in Germany cannot leave Germany from a data sovereignty or data residency law perspective, then we can immediately leverage AWS's reach over there, their data centers over there, and make sure that the data that you back up to the cloud will be always in Germany and will never leave Germany, thereby enabling organizations with a global footprint, especially in Europe, to meet their data sovereignty requirements from the get-go. Finally, with all the information that gets backed up across all the servers and across all the various sites, you will be able to have a single management console for all the data that gets backed up. Naturally, the immediate benefit of that for the organization is that they have full visibility and control of information. One of the things of the legacy solutions that we highlighted in the previous slide was that tapes provides a great way of storing things, but there are downsides of visibility of information and retrieval of information if it actually exists over there. You never know until you try to recover the information. And we've had certain incidents where customers are not able to recover information. So with Druva Phoenix, you will be able to know where all your information is, access that information, and you have search capabilities where you will be able to govern the data while giving you full control of that information at any given point. So in the event of a litigation or any compliance requirements, you have full access to data and you never lose information. Talking a little bit about DR in the cloud. This is something that we provide to our customers as well in the event of a disaster. So in the event of a disaster, what we essentially do is, since we back up all the data, we convert the images into AMI and make that available to a customer in the event of a disaster. the AMI gets put into their own AWS account, and they can immediately spin up servers or their virtual appliances directly from the cloud and naturally continue with business immediately within the get-go. This happens within a few clicks. So from a business continuity perspective, spinning up everything in the cloud is just a matter of a few clicks, and customers can get going immediately in the event of any disaster. One of the things that we do, and that's very unique to Druva, is the way we eliminate the unnecessary copies of information that gets created in the event of backups. A lot of legacy approaches talk about incremental forever or incrementals and the way they do differential backups or the way they do incremental backups. But one of the drawbacks of the way that happens is that you have to hydrate that information, because recovery of a particular date of information requires that the previous set of data needs to get rehydrated as well. And so making multiple copies from that perspective becomes a very painful process of managing. But the way we do it here with Druva Phoenix is that we do an ever-incremental, a true ever-incremental strategy, where we have a full copy of the data that gets backed up the very first time. And after that, we only do incrementals, which essentially means data that gets changed, we back that up directly to the cloud. And as a result, only very little information gets transferred to the cloud. Naturally, if you look at what happens across organizations, we've seen that on an average, anywhere between 0.5% of the total data to 1% of the total data actually changes on a daily basis. And so the amount of information that gets collected or changed gets immediately backed up to the cloud. Furthermore, we provide global deduplication capabilities where we are able to globally deduplicate, globally dedupe information across all your servers. And so the very little information that does get backed up, we also make sure that only a single copy of that data gets backed up. And so if there was any repeated data across servers that got changed or that exists, we only make sure one single copy gets transferred. That helps in reducing the bandwidth requirements in any offsite location where there are bandwidth limitations, and that helps in optimizing for performance directly to the cloud. All in all, because of ever-incremental backups and because of deduplication technology, we see a huge benefit that gets transferred immediately to the customer that helps in storage requirements, bandwidth savings, and ultimately what we have seen statistically speaking is about 80% of storage and bandwidth requirements gets saved from that perspective just by globally deduplicating information. Talk a little bit more about envelope encryption that I'd highlighted. Essentially what we do here is that if we create a key on a per customer basis, which is a key that is for the data, and then we encrypt that. Once we encrypt the key, what we store is a token. And so when the user or when the server gets into action and when they're doing backing up data, that key needs to get unencrypted or the token needs to get encrypted to get the key eventually, the data encryption key. So the way this happens is that we bring the token to the table, and the customer naturally will provide the key to unencrypt the token to generate the data encryption key. This way, it's very similar to a bank locker system where we provide the token and the customer actually gets to unencrypt it. This way, we ensure that Druva never has access to the key. There are no key management servers to be managed, and as a result, it's extremely secure from that perspective when it comes from a security perspective. And so customers will have full access to their data at any given point, and Druva will never have any access to it in the customer. Looking at data sovereignty, we talked about that a little bit briefly. Leveraging AWS regions, essentially there are 16 of them, we are able to provide full access to information in any particular region, especially when there's an organization that doesn't want their information to leave a particular region, and I gave the example of Germany as well. From a manageability standpoint, we have role-based access, so if there's an admin that sits in Germany who should have access to information in Germany only, then we have full role-based access controls available in the platform and a single view, a single pane of glass to manage all the information across all your sites that makes it very easy to manage from that perspective. When it comes to centralized site-level management and policy-based automation, you have full controls over that as well. You have the ability to provide granular controls to certain admins. You can manage all your workloads directly from one console, and you don't have to worry about any disparate solution or managing the various solutions, one for deduplication, say like a data domain box, or you're trying to have another backup solution from another perspective of a VM perspective. You want to back up that data as well. You don't have to manage multiple solutions. You will have one solution, and you can manage all that from a single pane of glass. Something that is very unique to Druva is the way we charge customers and how they utilize Phoenix from that perspective for their infrastructure. This is extremely new from the perspective of no one offers this, and we essentially let customers buy certain credits from us from a storage perspective, say 1 terabyte on a monthly basis. Sorry, not 1 terabyte on a monthly basis, but we charge credits that they can buy, which is essentially about 1 credit is 1 terabyte of data for a month. And they can purchase as many credits as they want, naturally, for their storage requirements. But the key thing here is that we provide full transparency into the utilization of the information, and they only pay for the amount of data that gets stored. And the data that gets stored is, of course, post-deduplication. And so naturally, if you start off with 100 terabytes, that becomes 30 terabytes post-deduplication. Then you buy the amount of credits for 30 terabytes. At the end of the day, after the first year, if you realize that you only stored 5 terabytes, then the credits for that gets deducted and gets charged to the customer, and the balance of 30 minus 5, say 25 terabytes, we roll that over to the customer, in the customer's account, over to the next year. It's just like the talking plans that are offered here from mobile phones, where you are able to roll over minutes. So this way, customer has the ability to purchase any credits, and if they do not utilize all that, that gets rolled over to them over to the next year. And this way, customers only pay for data that gets stored in AWS, which is essentially a pay-as-you-go model, and that helps customer utilize and manage and give full transparency into how they're charging, how Druva is charging them, and manage their budgets from that perspective. At the end of the day, if you look at an example over here, if you keep in mind all the moving parts that come into traditional backup, that comes with the legacy approach of backing up server data or data that resides in servers, we provide over 80% or up to 80% of total cost of ownership reduction when it comes to the amount of savings that we provide to the customer. And if you look at the moving parts of software licensing, maintenance, storage, management, that comes to about, say, roughly about 1.6 million. And this is an actual customer situation that we are showing over here, where an organization was paying up to $1.6 million. With Druva Phoenix and across all the servers and all the sites that they were managing, we lowered their total cost by over 80% and eliminated any management headaches that came along with that. And that is primarily because of no infrastructure requirements. There is absolutely no hardware requirements when it comes to backups to the cloud. We very highly efficiently dedupe the data, and because only single copies are sent over to the cloud, we are able to meet all their bandwidth requirements remote offsites as well. And then finally, pay as you go. You only pay for what you consume, and so there is no over-provisioning, under-provisioning of any hardware involved, and you eliminate all of those headaches as well. This is the dashboard board of the Druva Phoenix Cloud, where once an IT admin logs into the cloud, he will have full visibility over all the virtual machines that they are protecting, all the data that resides there, all the physical servers that they have across all the sites, and then ultimately you will actually get to see how much of savings you are getting directly from the technology, the global deduplication technology that we provide across all the servers. You will see how much source data you have, how much you're actually storing in the cloud, and as a result, how much you're paying for it. You have full access over all the servers. You can manage it. You can restore the information directly from the cloud, and you can immediately take full advantage of this console, which is a single pane of glass to manage all the sites and all the physical assets that you may have from a backup and restore perspective. Finally, we have also on the call today joining us Shay Credit, who is with TRC. He is a Senior Director of Technology at TRC Companies Inc. a national engineering, environmental consulting, and construction management firm that provides integrated services to the energy, environmental, infrastructure, oil, and gas markets. He brings over 15 years of IT experience and leads a technology team focused on delivering high-quality, cost-effective technology solutions that contribute to the business effectiveness of the organization. He is part of the Druva family, and without further ado, I'd like to hand over the presentation to Jason, who will now go over his use case and how Phoenix was able to benefit him from a use perspective. Jason?
Yeah, thanks, Shay. I appreciate it. Thanks for the introduction. So yeah, I work for a company called TRC. You likely haven't heard of us like you've heard of Druva or obviously Amazon. So I'll tell you a little about who we are. We're an engineering design consulting firm. So I have nothing to sell to anybody here other than you know, just how awesome Druva's been for us. We're focused on I'm going to say 3. It says 4 there, but I'll explain why that is. 3 main verticals: energy, infrastructure, and oil and gas. And really what we're doing is designing and engineering and in a lot of cases helping construct physical assets in the real world, like in energy, distribution and transmission, like overhead lines and facilities wrapped around those. Infrastructure, you think about roads, bridges, and highways. And then oil and gas, you think of you know, pipeline facilities, and distribution networks and things like that. So we've been around for quite some time, and we're really spread out across the United States. And why that's interesting, especially in this use case around Druva, is that we've grown a lot through acquisition. So we buy companies and pull them in where they're strategic to our company, and then we help you know, our customers now see us just as one TRC. And when that happens, we buy companies, and obviously what happens is you buy everything. You don't just buy the customers you also buy the infrastructure that they're using, and in this case, you know, the backup infrastructure and servers. And what we ended up seeing was there was a lot of different types of backup systems out there. A lot of the commonly known good ones that have been around for a long, long time, using tape and other. And then, you know, there's always this opportunity to kind of replicate and move data into a you know, main data center where it can then be backed up and those kind of things. And that was problematic, right? We wanted to, you know, spend less time worrying about our backups and less time investing in a very important task. But we saw the opportunity on the other side to use that time more effectively, and we wanted to take advantage of that. So on the other hand, we also have a lot of organic growth where it's not just through acquisition, where we're growing considerably. We see a lot of data. And as kind of Mike talked about initially, there's this problem of capital bets, as I like to call them, or we like to call them, where you're saying, you know, we know we're going to be in this region or in this facility for 3 years to 7 years based on your depreciation schedule. And we thought, oh man, you know, those bets are hard to come by. You know, we work in, you know, fields that are elastic. Just like you know, cloud services are elastic, and we wanted to take advantage of cloud. You know, we wanted to take bets on inserting people and inserting services, not on infrastructure and things like that. So we were at a point where we had multiple backup and recovery solutions. We had a lot of fully deprecated assets that we were ready to get rid of, and the administrative burden of dealing with all of that just wasn't strategic to us. And so we wanted to get rid of it. We wanted to just turn the problem over to somebody else, more or less, so we could focus. And we knew to do that, we had to move to the cloud. But beyond some of that, you know, cloud focus, we had some considerations, right? We have all these sites, they're disparate, they're not always in the middle of a big city. Often they're not. They're in, you know, fields where people are working, and so bandwidth was a consideration. We didn't want to, you know, have this backup solution, you know, fully utilize our lines and our resources, because those aren't just used for backups. They're used for all sorts of services. Obviously, the centralization of the management was so critical to us, because we had, you know, backup administrators focused on, you know, 3 or 4 different tools in some cases, and man, if we could just have one, tell me how we're doing, are we successful or not, and if we need to do restore, we come to that or not. But because we have a fairly large organization and disparate IT organizations, we also wanted to allow some of our operating segments to do restores, right? So they can manage, if they need data, go get it, restore it. You don't wait for IT. But we also didn't want them to mess with, the policy side, right? We have specific policies for retention and security and those things. We want to enforce those, but then allow kind of delegation of control so people could manage their own restores and ad hoc backups. So role-based permissioning was really important to us. Security, obviously, and Mike and Shay have done a good job of describing why that's important. It's obviously very important to us because we're stewards of our customers' data a lot of times, and we want to make sure we're protecting it just as they would, and have a really defendable and understood security model wrapped around that. And Shay and Mike discussed that. Outside of some of those technical requirements, we knew we wanted cloud, right? We were focused on it. We knew we wanted it, but there was this argument, right? Do we want to put it on top of EC2 inside of Amazon and build our own infrastructure around it, but it would be cloud infrastructure, or do we just want to go full SaaS and let somebody else manage it? And then obviously I've talked about the removing of administrative burden, and we had some retention goals as well to set forth. So we took some of these requirements, and there's some additional ones that I'm not mentioning here, but we took all of these and we put them in a list, and we said, all right, let's go. And we looked around, we called a lot of people, we looked to Gartner and groups like that and said, what do you guys think? Who's out there doing this? We're not used to this. And we came down to about 5 alternative solutions that we were really focused on. And we said, this is very new to us, this is a new frontier, let's go out and let's try them. Let's try every one of these suckers for 45 days and see what we get. And we took like data sets and common data sets and absolutely executed a 45-day proof of concept for each one of these. And the things we were measuring along the way were things like speed, right? We were streaming over the internet instead of going to local tape or replicating back to our home office, and so we wanted to make sure our backup windows weren't just going to be crazy, right? And then we were focused on capacity, stored capacity, because as you move to the cloud, right, you pay for consumption, as Shay described, and Mike as well. So we wanted to make sure we understood the costs. And also in that 45 days, we can start to look towards, okay, now what's it going to cost us for the next year or next 2 years based on what we think we know about our historical trends of data growth and things like that. Obviously, things break, and they break all the time, so we were considering, what was our success failure rate, and backups can fail for a number of reasons, and that happens, right? You can't necessarily get rid of it, but some applications deal with failure more resiliently than others, and we wanted to track that. One of the interesting things that we really focused on was software usage. Was it just nice to use? Were we comfortable with it? Was our administrative team looking at it and saying, yeah, this will work. It's not too much brain damage to just do a backup and do a restore and set up policies and procedures. And so it's not a measured term, obviously, but certainly we gave time to the thought of, is it okay to use, and could we bring junior admins in, and those sort of things. We opened up support cases with all vendors to see, how did they respond to our problems, if we had an actual problem, or in other cases we just wanted to make it up so we could experience the support cycle. So we made up silly questions at times and said, hey, how does this work, or this is broke, and just to see how they would respond and help us through those. And then we did restores and things like that just to make sure that we weren't only able to back up but able to restore from points in time and things like that. What we ended up finding was obviously Druva, because I'm on the phone here today with you guys, and the metrics that we saw for weekly storage costs really blew us away, and a lot of it absolutely has to do with, as Shay talked about, that incremental forever, that magic sauce that Druva's got was critical to us. We saw it immediately in 45 days. Some of the alternative solutions were already double or more the capacity or consumption used, because we're not having to do full backups, and we're not having to store data that we didn't actually need. So some of that comes with the deduplication as well, or a lot of it did. Initially we thought, no way we could duplicate all this information. It's just not feasible. Our data's different or special, or doesn't compress well, or whatever the reasons why we had made up in our minds it just wouldn't work. We were proven really wrong really quick, and it really surprised us at the end of the day, to see a 2-to-1 deduplication rate versus none, none in other cases, and just physical or storage. And as we put all of it together, we saw a ton of cost savings, and the 60% is actually very true to us when you start looking at the full suite of things we just didn't have to do anymore, like managing tape libraries and managing tapes and shipping them off to caves to be stored and paying for the space of storage, the physical space of storage, those kind of things. It really, really, really added up to us. And there was some thought process around circuit costs and how we might be able to reduce some of those circuit costs because we're not backhauling or trying to do these synchronous replication topologies to protect our data. So we looked at all those things and we're like, oh my gosh, why would we not do this? Let's go with it. So we put Druva in, and we started out, you've got to install the agent, and you've got to configure the policies, and then you say, okay, go, run. Let's see what happens. And that's exactly what happened, and about that fast, honestly, as well. And then, it took some time for us to get the data that we had from about 20 servers. We weren't doing our entire company at this point. We were just focused on 2 of our operating sectors. And we said, okay, bring that data over. And it was about 45 days, and we got 20 or so terabytes into our system. And then we started just kind of doing our incrementals forever. Now we're in that, still in that decommissioning legacy side. But also we've got this, Druva has enabled us through some reporting and things like that to do chargeback, so we can start to bill usage back to business units instead of trying to incorporate it into this large, allocation fee or something like that. You can say, okay, local company here in Kansas City or Denver or wherever, you can say, okay, this is how much you guys are using, so your business unit should pay for that. And that's been a really interesting opportunity for us. I mentioned low bandwidth sites there, and I want to make sure I pointed at it. We have one site that was more or less dial up. I mean, it felt that slow, and we're still able. It was 768K, and we're still able to do our backups and syncing, and it worked pretty well, given bandwidth throttling and the compression that we saw. So looking forward, what are we doing? We're working, I mentioned before, we're only doing 2 of our business units right now. It's become just kind of a no-brainer. We're going to go ahead and finish the rest of TRC. Sometimes we're waiting on assets to finish depreciating. Sometimes we're just waiting on focus to get to that group instead of trying to boil it all at once. So somewhat of a management problem there. And we're looking at our RTOs and we're saying, man, we could approve a lot of these, and we can move to the Cloud DR, which we didn't initially integrate or implement. And so we're excited about all of that, and we've joined the customer advisory board. Our CIO, JP Sani, sits on this, and one of the things I'd love to say as my time kind of comes to a close here is that more and more we're seeing in this customer advisory board, it doesn't feel like Druva is, we're certainly paying them for the services, but it's not as if they're, just this software company who doesn't really care about us. They're absolutely interested in understanding what we need and why it's important to us, and showing us roadmaps, and it's become a really collaborative environment for us, beyond just vendor and consumer kind of relationship, which you tend to get stuck in a lot of ways. We've worked a lot to really accelerate some value-added work. We've got smart guys who are focused on backups, and we thought, man, these smart guys could be used elsewhere and provide way more advantage or effectiveness to our company versus just focused on backups. So we got to re-leverage some of our resources there and some of our investments, and it's been a great journey for us. We've been really excited to be partners with Druva over the last year, and that's my time for today.
Okay, well, thank you very much, Jason. That was awesome. And I will say from my part, I've noticed that Druva as a partner works just as assiduously with AWS as evidently they do with you as a customer. So Druva are very engaged with AWS as we kind of improve our technology stack, and Druva, increasingly provides additional features to take advantage of those. So it's been a great relationship. Couple areas of next steps. So there's a free trial available of Druva on the AWS Marketplace. These are Marketplace is a place for AWS partners to list software for one-click or easy deployment in your AWS account. So I encourage you to go check that out. Druva also maintains a variety of videos that specifically reference AWS at the location on your screen. And of course, you can always come try out AWS. We have a free tier, so extensive ability to check out the platform with little risk. So with that, let's go ahead into our Q&A section. It looks like we have about 9 minutes left. We are going to try to keep it. We will let you go right at the top of the hour. We want to respect everybody's time here, and we thank you for the time you've already invested in the webinar today. So this would be a question for Druva. I think it kind of speaks to some of the questions around performance Jason touched on as well. So will cloud backups be very slow since we don't have any local or on-premise appliances or hardware to maintain? Maybe we could speak a little bit more about performance for Druva.
Yes, sure. I can address that. Absolutely. You know, one of the things that we have noticed across a lot of organizations is that they have a lot of remote sites. And with the remote sites, we have seen that bandwidth is always a constant struggle and a bottleneck for folks to, you know, do what they do every day, and especially for utilizing that for backups. And so, at a very high level, there are a couple of things we do. One is we do forever incrementals. Forever incremental means we make only one full copy of all your data, and if there are any changes from there onwards, we only back up the data that incrementally changes. And so if you look at it from that perspective, the information that gets to the cloud directly from your remote site is very little and very small to begin with. Further, global deduplication, as Jason mentioned, can be in the order of 2.5x, 2x to 3x, anywhere in that order. And so we further reduce the amount of data that goes over to the cloud because we globally deduplicate all the data across all the servers and make sure only one copy of information goes to the cloud. Finally, if that's not enough, where all the information that we are sending over to the cloud is very little and we are able to save across and only one copy is sent, then we also have a second option called Cloud Cache. Cloud Cache is essentially a local cache where you can store all the data locally wherever you want, and you can seed the data that goes into the storage over to the cloud at non-peak hours or at your schedule, like over the weekend or something, where information eventually trickles down to the cloud, and you always have a hot copy of the data from a restore perspective where you have access to that information at very high performance locally across your network. Hopefully that answers the question.
Great. Yeah, that sounds great. So it sounds like we've got a couple of different options. We can stage restores locally or stage data for local restore, or we can store everything up in the cloud. And we basically have an option based on our own requirements.
Yep,
Fantastic.
A complete no hardware solution, yes.
Perfect. So we have a question specifically for Jason, if you're still on the line. Can you describe the restore experience? Did you attempt to do full system restores? What was that experience like? In your POC, and I guess if you've operated Druva for some time.
Yeah, no, certainly we did. We wanted to understand it fully, right? It was such a awkward kind of place for us to think about, or it's new and different, right? So we did do full restores. And what's cool about it is you think about, you know, you don't have a system on-prem on your domain where you can say like, okay, we built this new server, we install an agent and go. So you've got this opportunity in Druva to say, okay, it's the same feeling, right? You go in, you say, I want to restore this D drive, for instance, and you say, okay, restore that, and then it says, what server do you want to put that on? You know, do you want to keep it on the one this came from, if it's available, or do you want to point it somewhere else? And so we clicked it and let it run. It does take time, right? It's got to stream it back over the wire. But hopefully you're not doing those, you know, all too often. But when you do it, you know, it's pretty efficient. It seemed to me we did about 1 terabyte where we restore it. I wish I could quote a number for you, but I don't remember how long it took. But it was done within a day, you know, stream it back kind of thing. And that was a higher bandwidth site. But we were able to restore back to the same server as well as to another server where it was available. We hadn't tried the Cloud DR. In fact, when we did our initial POC, that wasn't an available feature. I mean, they continue to innovate and drive new features and services around their products. So we're excited to test Cloud DR next.
Great. Well, thank you for that. The next question would be for Shay, and it touches on the DR feature or DR features for Druva. So it sounds like we've got, using Druva, we can do disaster recovery in the cloud. And I think that's Druva leveraging cloud technologies and converting customer machine images into Amazon machine images or AMIs. The question was specifically, can we fail back to on-premise if we use the cloud for a DR site or as a DR recovery location once we kind of repair the data center, or maybe we're switching to a new data center doing some sort of upgrade motion? Can we fail back to our on-prem infrastructure after a DR event?
Yes, yeah, sure. So first, can you fail back? Absolutely, there are ways to do that. But essentially, from a disaster recovery perspective in the cloud, you don't actually have to invest in any location. We back up your data and take snapshots of your environment naturally, convert it into AMI as an Amazon machine image, as I mentioned earlier, which is a special type of virtual appliance that is used to create a virtual machine within EC2 or AWS. And this way, within a few clicks of a button, you are able, in the event of a DR, to spin up your infrastructure within Amazon. And in the event where you need to bring it back, there are ways to do that as well.
Okay, wonderful. So this is a question specifically about data governance and maybe about multi-tenancy. So are all the data going into the data we're backing up, is that into Druva's AWS account and a Druva controlled bucket, or can this be a customer owned AWS S3 bucket?
So that's a great question. So essentially, we take out all the management headaches out from our customers. When they buy something from us, they deal with us directly. And so all the data that gets stored in the cloud, it is directly into AWS, and that's Druva's account. And it gets stored there. Recovery from there also happens. But one of the reasons why we do that is we provide complete segregation of information while maintaining all security controls such that there is the information that is relevant to a particular customer remains secure at any given point. And so that gets managed directly by us. And in the event you have to, and when you work with us, we take care of all of that for you. You tell us where you want to do it, where you want to store your information. We work with you with the data center of your choice, store that data in that particular region, all in our account, and we manage all that infrastructure requirements from the back-end perspective for the customer, and they don't have to worry about that.
Okay, well, thank you for that. So at this point, we're out of time today. So I'd like to encourage the audience to please fill out the survey, which will pop up at the end of the webinar. Thank you very much for your time. We have a few specific technology questions that popped up in the chat, and we'll go ahead and take those up with those customers offline. So thank you very much for your time today, and appreciate you attending the webinar.
Thank you.